how exactly does a lonely, isolated patent clerk completely rewrite the fundamental laws of the universe in just a single year? It's a question that honestly borders on the mythical. Picture this. You've got a young man, a Class 3 technical expert, sitting quietly at a wooden desk in a burned patent office, right at the dawn of the 1900s. He's totally cut off from established academic networks. He failed to get a university assistantship. He has no lab, no senior mentors guiding him, and absolutely zero access to the rigid peer review systems of the time. And yet, from this total academic isolation, using literally nothing but a pen, paper, and the sheer force of human thought, he is about to fundamentally alter the very fabric of our reality. Today, we're diving into an explainer about light, shadow, pure mathematics, and honestly profound human tragedy. Before we delve into those shadows, just a brief note. This explainer utilizes historical letters, academic papers, and biographical data for educational analysis under fair use. All right, let's quietly step back in time. The Annus Mirabilis, Light, Shadow, and the 1905 Miracle. Part 1, the Miracle Year, spanning from 1902 to 1905. So, because he was operating completely outside the rigid paradigms of late 19th century academia, our patent clerk was essentially forced into deep independent reflection. He was free to ask the sort of reckless questions that established professors just avoided. And this quiet contemplation, it absolutely erupted. In a span of just a few months in 1905, 4 revolutionary papers were published in the journal Annalen der Physik. Look at this timeline. June, the photoelectric effect. July, Brownian motion, which actually proved the reality of atoms. September brought special relativity, and then November, mass-energy equivalence. In under 6 months, the fundamental building blocks of existence were entirely redefined. Let's calmly unpack that first major breakthrough, light quanta, or as we know them, photons. Up until 1905, physicists viewed light a lot like a continuous ocean wave. But this first paper proposed something highly counterintuitive. It suggested that electromagnetic radiation actually travels in a finite number of discrete, individual energy packets. It's like a stream of tiny, separate packets, rather than a continuous wave. This beautifully solved the mystery of the photoelectric effect. It explained exactly how light brings just enough energy to knock an electron right out of a piece of metal. It laid the entire foundation for modern quantum physics, and, it would eventually earn him the 1921 Nobel Prize. Now, moving to the next massive conceptual leap, let's look at special relativity. The genesis of this theory is so wonderfully grounded in everyday observation. The spark actually came while he was just riding a streetcar in Bern, staring at the city's clock tower. He realized that if he were traveling away from that clock at the exact speed of light, the clock's hands would appear completely frozen to him, while his own pocket watch would keep ticking normally. This brilliantly illustrates a truly radical realization. The speed of light is constant for all observers, no matter how they're moving. And the implication of that, it means absolute space and absolute time simply do not exist. They are illusions. They're fundamentally interwoven and entirely relative to whoever's observing them. If you're finding this quiet journey through the hidden corners of history compelling, please take just a moment to subscribe to @FamousLivesBio and like this explainer. Your support is what allows us to keep crafting these historical dives. All right, let's return to the human element behind all this math. Part 2, the Mileva Marić mystery, a human shadow. Right behind the brilliant light of those 1905 papers lies a really intense intellectual and romantic partnership with his first wife, Mileva Marić. Now, in the late 19th century, it was exceptionally rare for women to enter physics in Europe. Yet, there Mileva was, one of the very few female students at the Zürich Politeknik. Archival records confirm she had excellent marks, really demonstrating a formidable mind stepping into a heavily male-dominated arena. But the lingering question is, was she simply a sounding board for him or an uncredited co-author? Sadly, her academic trajectory was abruptly and painfully disrupted. In early 1901, she faced a secret, out-of-wedlock pregnancy, and later that year, while 3 months pregnant and under an immense amount of stress, she sat for her second attempt at the final diploma examination under Professor Weber. She failed, and just like that, her dreams of writing a doctoral thesis were tragically halted. So looking back, how do we actually measure her scientific contribution during that miracle year? Well, the historical debate centers almost entirely on 54 surviving letters. These were exchanged between the couple from 1897 to 1903. These intimate documents intertwine their romantic emotions with incredibly complex scientific musings, and they serve as our primary lens into their collaboration. And within those 54 letters lies one single sentence that has fueled decades of intense speculation. Read this exact quote from Albert in March 1901, quote, "How happy and proud I will be when we two together have victoriously led our work on relative motion to an end." Notice that phrasing, "we two together, our work on relative motion." For some historians and feminist scholars, this language strongly suggests that Mileva was fundamentally involved in conceptualizing the theory of relativity. Let's impartially balance the arguments here. On one hand, we have a really tantalizing claim by Soviet physicist Abram Iyov. He stated that he actually saw the original 1905 manuscripts and that they were signed Einstein Marić, which used the Swiss custom of adding the wife's maiden name. The problem? Those originals were destroyed, making it absolutely impossible to verify today. On the other side, historian John Stachel provides a really fascinating linguistic analysis. Stachel points out that while Albert used "our" when discussing their shared student thesis work, he invariably switched to "I" and "my" whenever detailing the specific electrodynamics concepts that eventually became the 1905 relativity paper. Furthermore, the remaining physical evidence poses a real challenge. Out of those 54 letters, only 10 from Mileva actually survive today. And crucially, in those 10, she never once mentions important physics topics. As Stachel notes, there are no published papers by her and really no objective evidence of creative scientific talents in the written record. So with so much lost to time, the true extent of her collaboration remains this perpetual mystery. It's a shadow lingering just outside the frame of history. Part 3. The Burden of Genius. Destructive Reality. From the mysteries of his youth, we have to fast forward to a devastating legacy, the moment where pure mathematics met human destruction. E equals mc squared. It is perhaps the most famous equation in history, and it beautifully asserted that mass and energy are merely different manifestations of the exact same reality. But hidden right within that elegance was a dark truth. An unimaginably terrifying amount of energy could be released if the tiny nucleus of an atom was disturbed. The mathematical miracle of 1905 was slowly transforming into a nightmare. This beautiful, elegant equation ultimately paved the way for the most terrible weapon ever conceived. In August 1939, acutely aware of the implications of his own math, Einstein warned U.S. President Roosevelt that Nazi Germany was likely pursuing atomic weapons. And it was this singular warning that prompted the highly classified Manhattan Project. Now, though he didn't directly build the bomb himself, his theoretical framework and that specific political nudge were the catalysts. It all culminated in the devastating nuclear bombings of Hiroshima and Nagasaki. For a man who was a lifelong pacifist, the guilt was absolute. In 1954, right near the end of his life, he wrote an incredibly powerful anti-war letter to Japanese editor Katsuhara. And I want you to really hear the heavy melancholy in his words here. "I was well aware of the dreadful danger for all mankind if these experiments would succeed, but I did not see any other way out." He actually later referred to his letter to Roosevelt as his one great mistake. The man who unlocked the deepest secrets of light and time spent his final years mourning the darkness he inadvertently helped unleash. Which leaves us right here. The Annus Mirabilis was an undeniable triumph of the human mind. It was born in isolation and perhaps, just perhaps, shared in the quiet intimacy of a doomed marriage. But when the elegant absolute laws of the universe end up unlocking the tools for our own total destruction, does the pursuit of absolute truth really justify the ultimate cost? Take a moment to quietly ponder the heavy price of unlocking the cosmos. Thank you so much for joining me on this explainer.